Okay guys, so today I'm planning to use a tutorial from Amazon Web Services, getting started with Amazon Web Services, full stack developer. Okay, so now, without any further ado, let's open the tutorial and start reading and creating the tutorial. Learning path full stack developer. The best probably would be to be a full stack developer. So what is a full stack developer? You want to learn about both client and server-side code and understand how the full suite of technologies making up a website work. On the client side, you want to build everything you actually see on the website. For example, the layout, the positioning of the text and images, color, fonts, buttons, etc. Using typically HTML, CSS, and JavaScript. This is the front end. On the server side, you want to create algorithms and business logic to manipulate data that's received from the client side. So this is it. What we will learn: deploy a web application to Amazon Web Services, create and host a web application that renders Hello World, and set it up so users can easily access it. Build a serverless backend, create a serverless function to trigger based on custom inputs in a text field, store data into a database, store data from the custom input field, and render the text on your website. Get started. Build basic web application. I'm gonna open this into a new tab. This tutorial will teach you how to build a basic web application in about 30 minutes. Okay. Let's see if we can build it in 30 minutes. Introduction. Build a basic web application. Follow step-by-step instructions to build your first web application. Overview. In this tutorial, we will create a simple web application. You will first build a static web app that renders Hello World. Then you will learn how to add functionality to the web app so the text that displays is based on a custom input you provide. What you will learn. This tutorial will walk you through the steps to create the sample web application discussed above. You'll learn to create web application, connect the web application to a serverless backend, add interactivity to your web application with API and database. What I like about Amazon Web Services is the common structure which they have on all their tutorials. Overview, what you'll learn, application architecture eventually, and after that the modules. In the modules, also you can easily recognize the common structure which they use. We will see that very soon. The diagram below provides a visual representation of the services used in this tutorial and how they are connected. This application uses Amazon Web Services Amplify, Amazon API Gateway, Amazon Web Services Lambda, and Amazon DynamoDB as pictured below. This is a very typical architecture of a modern application. This is what we're going to do. It's called also cloud native, serverless, service-oriented architecture. And the lambdas, you can say those are microservices. Not exactly though, not exactly. But those are services. So as we go through the tutorial, we will discuss the services in details and point to resources that will help you get up to speed with them. Nobody is building anymore the application in-house. The application building actually turns to be something like installing and building a website with a WordPress, installing the proper plugins and make them work together. Right now we are not working with the plugins of WordPress, we are using the services of Amazon Web Services. You have to learn eventually Amazon Web Services, Google Cloud Platform, and of course Azure, Microsoft Azure. They offer the very same services, name it differently, slightly different, philosophy is different, the names are different, but outcome is always the same. So the user is going to communicate with AWS Amplify, which on its turn is gonna contact the Amazon API gateway, which actually it's a facade for the requests. We are gonna create Amazon Web Services Lambda, which is gonna use Amazon Web Services Identity and Access Management in order to allow this Lambda to communicate with gateway, and this Lambda is gonna communicate with Amazon DynamoDB modules. This tutorial is divided into 5 short modules. You must complete each module in order before moving on to the next one. So in the sequence, let's go to the first one. Let's first read all of the modules. Create a web application. This is a simple HTML application. Deploy static resources for your web application using Amazon Web Services Amplify console. Build serverless function, 5 minutes. Build a serverless function using Amazon Web Services Lambda. Link serverless function to web API, 5 minutes. Deploy your serverless function with API gateway. Create data table, 10 minutes. Dynamo, by the way, is NoSQL database. So persist data in Amazon DynamoDB. Add interactivity to the web application, 5 minutes. Modify your web app to invoke the API. You will be building this application using the Amazon Web Services web console accessible directly from your browser. Okay. So in the module 1, what we are gonna do? Again, look, the structure is the same. This similarity in the structure is very nice. Introduction, create web application, build services function, link serverless function to web application. Those are the different modules. Actually, interactivity. Okay, so module 1, create a web application. In this module, you will deploy static resources for your web application using the Amazon Web Services Amplify console. Introduction. In this module, you will use Amazon Web Services Amplify console. Let's open this. Get started, blah, 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 blah. Amplify is similar to Google Firebase. To deploy the static resources for your web application. In subsequent modules, you will add dynamic functionality to these pages using Amazon Web Services Lambda and Amazon API Gateway to call remote RESTful APIs. REST stands from Representational State Transfer, and it is an architectural pattern for creating web services. API stands for Application Programming Interface. Thus, a RESTful API is one that implements that architectural pattern. All of your static web content, including HTML, CSS, JavaScript, images, and other files, will be hosted by Amazon Web Services Amplify. We selected the Amplify service since it makes it straightforward to host and deploy static websites. Your end users will access your site using the URL exposed by Amplify. So Amplify takes care of exposing your services, the services which you're using. If you're nervous about working with so many new things, don't worry. You won't use other Amazon Web Services right now, and you also don't need to run any web servers. A server is software or hardware device that accepts and responds to requests made over a network in order to make your website available. The website will be extremely simple hello world page, and we will add more functionality in later modules. For most real applications, you will want to use a custom domain to host your site. A custom domain is a unique brand name that identifies a website such as www.amazon.com. If you're interested in this, Amplify provides support for custom domains as well. As you can see, you don't have to care about anything. Even the SSL certificate, I guess, is going to be issued for you by Amplify. What you will learn: how to create Amplify application, how to update files for a website directly to Amplify, how to deploy new version of a new of web page with Amplify. Actually, they're not going to use a pipeline, a CI/CD pipeline in this case. Manually, we are going to deploy the application, but we'll learn a very important concepts, key concepts. Static website. A static website has fixed content, unlike dynamic websites. Static websites are the most basic type of websites and are the easiest to create. All it takes is creating a new HTML page and publishing them to a web server. Web hosting provides the technology services needed for your website to be viewed in the internet. Amazon Web Services. Regions separate geographically areas that Amazon Web Services uses to host its infrastructure. These are distributed around the world so that customers can choose a region closest to them in order to host their cloud infrastructure there. And we finally get to the meat of this tutorial. Implementation. Create a web application in Amplify console. Open your favorite text editor in your computer, create a new file, and paste the following HTML text. Cannot be simpler than that. Zip compress only HTML file. 4. In a new browser window, log into Amplify console. We'll see that just in a second, but let's follow the tutorial. I'm gonna create it in trash. I'm gonna call this Amazon Web Services. I'm gonna create a new folder which is called Amazon Web Services. And I'm gonna call this folder, this project, Full-Stack. Inside, I'm gonna create a new index HTML file. Of course, I have to remove the txt extension, so it's gonna become an index HTML file. And just for fun, I'm gonna run my PowerShell, navigate this location, Amazon Web Services, Full-Stack, and I'm gonna start my editor, which is Visual Studio Code, my editor of choice, Visual Studio Code. Let's wait just a second, as the people used to joke. Actually, when you start Visual Studio Code, you're starting a new browser. Okay, so as a rebus, blah 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 blah. Okay, okay. Let's wait a second, because if I type right now exclamation point tap tap, the HTML file is going to be created for me. The code for the HTML file is going to be created for me. I'm going to turn off the power. I'm going to stop charging my computer, my laptop. So let's try. No, still doesn't work. Okay. I don't know. At one moment probably will start helping. Yeah, here we go. So you just have to be a little bit more patient. Doc type HTML, which is a standard. Oops, what did I do? Yeah, it's trying actually to beautify my code. I have such a plugin. So doc type is an expression which tells the browser that we are going to use HTML5, HTML language English, head, meta, charset, UTF-8, meta. Okay, so let's compare with what we have here in the tutorial. Probably we'll have the same thing. HTML, head, meta, characters, hello world title. Okay, let me put hello world title instead of the title which we have right now. I'm gonna type it actually, hello world. Oops. Okay, so I'm not very careful. I have to type more and waste more time. Hello world body. So let me put it in a H1 tag actually, and I'm gonna say hello world. Okay, just slightly twisted tutorial. I'm gonna twist it a little bit. Okay, so that's done. Now what do we have to do? Save the file in index.html, zip compress the file. Okay, here we go, I have it. Click with the right mouse button, add to archive, choose a zip, and zip it. Okay, so I have it. In the new browser window, log into Amplify console. Let's open the Amplify console. Okay, I'm gonna close this. This page actually explains what the Amplify is, features, continuous workflows, feature branch deployments, one-click custom domain setup, global availability, instant and atomic deployments, password protection, how it works, connect to your repository. In this case, we're not going to use repository. Configure build settings, deploy your application, and that's it. Okay, so I'm going to put the links to this URLs under the video. Fastest, easiest ways to develop mobile and web apps that scale. Okay, get started. Amazon will amplify a set of programs, blah, 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 blah. Develop, configure backend, deploy backend, connect application to backend, deliver, connect your repository, configure build, host web application, manage, invite team members, log into admin UI, manage content and users, get started. Host your web application. Probably this is what we're supposed to do. Let me look again here. In the new browser, we'll log into Amplify. No, we will be using Oregon. Oh, that's quite important. And I'm on Oregon already. Okay. Under deploy, click the orange get started button. Get started. Under deploy, I didn't see deploy. They have changed the interface, but host your create an application backend, host your web application. Connect your Git repository to continuously deploy your front end. You see how the automation actually works. Okay, React, Vue, JavaScript. JavaScript does mobile application, so get started. Get started, host your web application. So GitHub is one option, Bitbucket, GitLab, code commit. This is the source control management, which is a service of Amazon Web Services. Deploy without Git providers. This is what we're going to use right now. Deploy without Git provider. This is what you should see on the screen, okay? Click the orange continue button, continue. In the app name field tab, get started. Okay, environment development. Select the drag and drop method. This is what you should see on your screen. Okay, so let's follow the tutorial. Continue. Give it a name. I'm gonna give the name actually. I'm getting started. Okay. Come on. Come on. Okay, I'm gonna follow exactly the tutorial getting started. Okay, getting started. In environment tab develop, drag and drop Amazon S3 or any URL. This zip file actually can be put in Amazon S3 in any URL or drag and drop. We're gonna drag and drop. Choose a file which we just created, this file, and is gonna be deployed. But let's follow the tutorial. Dev, select the drag and drop method. This way you'll see this is what it is. Click on choose a file. Select the zip file to create it in step 1. Click the orange save and deploy the button. This is trivial, it's not that interesting, it's not very exciting, but we'll come to the exciting parts. Projects. I put it into the trash in Amazon Web Services, in Full-Stack, and here we go, index, open, index zip. Click Save and Deploy button. After a few seconds, you should see a message deployment successful completed. Yeah, and it's going to give us the URL where we can access our newly created HTML file. Save and deploy. Save and deploy. It's spinning. Okay, great, great, great. Look at this. Look at this. By the way, for the simple HTML files which are deployed using a zip file or archive, or for projects which are using source control management, Git usually, it looks the same backend. We don't have backend right now. We are not gonna configure this, I believe, right now. If I'm not mistaken, we will do something, but just in a minute in the next module. So let me open the application and we should see hello world. Okay, so that's it. Now let's continue with the next. Test your web application. Click on the link on the domain. Your web app will load a new browser tab and render hello world. Congratulations. Okay, we did it already and we saw that it works. This is the test. Okay, congratulations. I'm gonna keep all this open. I'm just gonna put something like a divider here. Okay, so now test your web application. We tested already the application architecture. Here is what our architecture looks like right now. This is the user, this is us. When we access here hello world, and this is the Amazon Web Services Amplifier. It's pretty minimal for now, as we are only using the Amazon Web Service Amplifier console. We now have live web application users can interact with. Next, we will create a Lambda function. Okay, so I'm gonna move this away after the divider on the right hand side of the divider, and we will continue with build a serverless function. Now, this is a little bit more exciting. We are creating a function, Lambda function, into Amazon Web Services. Module 2, build a serverless function. Its module will build a serverless. In this module, you will build a serverless function using Amazon Web Services Lambda. Introduction. In this module, you will be writing a small piece of code in Python, JavaScript, or Java. That's up to us, to be used in a later module to add interactivity to your web page. You will use Amazon Web Services Lambda service. I'm gonna open this. Gives us the explanation what the Lambda service is. I'm not gonna read it right now. I'm gonna read a brief introduction. A computer service that allows us to create serverless functions. A serverless function eliminates the need for software and hardware management by the developer. Instead, applications are broken up into individual functions that can be invoked and scaled individually. Looks like a microservice architecture, but it's not exactly this. Of course, you can build a microservice architecture with lambdas as well if you like. For each one microservice, you have to use a separate database, and also they should use the advanced message queue protocol. One implementation of this is Rabbit message queue, for example. These serverless functions are triggered based on a specific event you will define in the code. It's also a very affordable service since you're only charged for the number of events you process, not the idle time. Best of all, you do not have to worry about managing any servers. Okay. What you will learn creating without no frameworks, no nothing. What you will learn: create a Lambda function from scratch using Amazon Web Services console in Python, JavaScript, or Java. Create JSON events in the Amazon Web Services console to test your function. Key concepts: computer server service service that provides computational processing power. Serverless function. Piece of code that will be executed by a computer service on demand. Lambda trigger. The type of event that will make a Lambda serverless function run. This can be an Amazon Web Service or an external implementation. Create and configure your Lambda function. Now we have to do more things here. I'm gonna use JavaScript, not a Python. If you like, of course, you can go ahead and use Python or Java, whatever it's more convenient for you. In the new browser tab, log into Amazon Web Services Lambda console. This is exactly what I'm gonna do now. Here it is, the Lambda console. It's loading right now. US West 2, Oregon. This is very important. The Lambda server to be in the same region where our front end is. Amplify login, custom message, amplify login. We already have some functions. We have already 4 functions. Amplify login, create, out challenge, out challenge, out challenge, out challenge. Okay. I haven't created this. Make sure you note what region you're creating your function is. Okay, so I'll pay attention on that. It's Oregon. It's US West to Oregon. Let's stay there. You can see this at the very top of the page next to your account name. Click on the orange create function button. Under the function name, put hello world function. I'm going to remove all these resources once I finish with creating this tutorial. Author from scratch, use blueprint, container image, browse serverless app repository. So they have templates, a lot of things, a lot of code is already created. Basic information, I'm going to put the hello world function. I'm going to go back and select Node.js 12.x from the runtime dropdown. I'm not quite sure if we have to choose 12.x. Node.js because the tutorial is old, so I could of course choose Node.js 12.x, but they're backward compatible, at least they should be, so why don't we try with Node.js 14.x and see what happens. Change default execution role. Execution role, create a new role with the basic Lambda permissions. Okay, so a new role is going to be created. Advanced settings, code settings, signing, code signing configuration optional. VPC, that's virtual private cloud, optional. Info, if you want to create a virtual private cloud. Otherwise, it's going to be created by the system for us. Click the orange create function button. You should see a green box at the top of your screen with the following messages. Successfully created the function. Replace the code under the code with this one. Okay, so the only change I have made so far into this tutorial is that I have chosen Node.js 14.x, hoping and keeping my fingers crossed that it's gonna be backward compatible with 12.x. We'll see. Create function, so we'll get it now. Now we have to put the body of the function. It's gonna be quite simple, and of course, as I said, the tutorial is old, so we have to figure out some things ourselves. Look, actually it's pretty straightforward. Hello world function, function overview info, hello world function layers 0, add trigger, add destination. We have a test, and here we have the ID, even a text editor, which will allow us this is what we have in index JavaScript. Let me follow the tutorial. So you should see a green box at the top of your screen with the following message: successfully created the function. I didn't pay attention. Oh yeah, here we go. Celery created the function hello world function. You can now change its code and configuration to invoke your function with test event. Choose tests. I saw test. Yeah, choose test. I definitely want to invoke it. Choose test. Choose test here as a tab or just click test here. This is what it's not clear here. To invoke your function with a test event, choose test. Do we have a test event? We don't. Configure test event. So first we have to configure test event, I believe. Okay. So now replace the code and the function code with the following. Exports handler equals async event. Okay, this is the event const response. Return response. Status code 200 body JSON stringify hello from Lambda. I'm almost tempted to leave this exactly as it is, but let me do something else. I'm not gonna remove that. I'm just gonna comment out whatever we have so far, and I'm gonna put the code which they recommend. So export handler async event. So far so good. It looks exactly the same. Let name JSON stringify hello from Lambda, and here we have event first name, event last name, and that's it. Create a JSON object with our response and store it in a constant. Okay, this is exactly what the example did as well. Body name, body JSON stringify. It's the same JSON stringify name, return response. Okay, so that's it. I don't think we need something else. Do we have to save it? I believe we have to save it. So, okay. Click the orange button, the orange save button on the top of your screen. I don't see on top of my screen an orange button which says save, but I have chosen from here, from the menu, save. Okay. I don't see any button, orange button save. No code, signing configuration, edit, blah, 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 blah. Node.js 14.x. I don't think it matters too much for such a simple thing, but let's continue now, reading further. Click on select a test event. Let test our new function. Click on select a test event at top of your screen. From that drawing, configure test event, okay? I agree, I have seen that. Configure test event. Now, how should we call it? From that drop down menu, click configure test event. On the event name, put hello world test event, okay? Do that. Event template, event name. Where this hello world comes from? Event template. Oh, those are templates. Hello world, mobile backend, Lex, Amazon, Lex, book card. Those are the templates. So create new test event. Okay. Now, if you remember, we have two properties: first name and last name, which we supposed to get from the event object and print it and return it actually. So first name. Okay. There is no indentation, but okay, here we don't even have your indentation in the example. Click the orange create button at the bottom of the page. Here we have a create button. Okay, so first name, I don't see any syntax errors and problems, so I'm gonna create this test event. Okay, now probably I should be able Hello test event. Maybe this dot represents the fact that it's default, it's selected. Who knows? Okay. Click the orange create button on the bottom of the page. Your Lambda function. Test your Lambda. Click the gray test button at the top of the page. Click the gray. I didn't see a gray button test. I see an orange button test. Total copy rm actions create alias export delete function. Okay, that's fine. Oh, I don't see a gray. Obviously they have changed the color, so I should be able to run test pro, for example. Function lock, blah 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 blah. Duration, status code body, hello from Lambda, and I don't see the name. Actually, that's quite interesting. So function log start required, blah 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 blah. Request ID. I'm not gonna battle with this tutorial right now. Adler test execution results. How come? Look at this. Now let name. Okay. Hello from Lambda event. Here it is, event dot first name event last name. These properties of the object should have, if I go to test, I can see first name, last name. So go back here, first name, last name. Those are the special quotation marks. Everything looks fine to me. I'm not gonna battle with this right now. Obviously, somewhere there is a problem, but because I just see hello from Lambda, that's it. So the event, is the event passed? Probably it is, but stringified event Lambda. We see only the first part. Let me see if I see the comma. Hello from Lambda. Where this comes from? Exclamation mark. Hello from Lambda. What? This is hello from Lambda. What is going on here? Let me completely delete this. File, save. I'm just gonna consort this for any case. I don't think I need it somewhere, but okay. Just for any case. Hello from Lambda. File. Save. Okay, let me test it again. How come? Hello from Lambda. Response. How come? At the layer. Edit version rm info. What is that? Runtime settings. It shows me the result from my previous code. The changes I did on index JavaScript are just ignored. Maybe I should click deploy. Okay. Changes deployed. Now test it again. Now it's much better. Okay, so here it is, the secret. The tutorial, as I said, is old, so it's not a save, but something else. Actually, you have to click on deploy. Okay, so long story short, you have to deploy you have to deploy, and after that you can test it, and it gives me the expected result. Body hello world lambda from lambda other Lovelace. Okay, so everything works as expected. We tested. Let's continue further. Then you now have a work lambda. Okay, application architecture. Now that we are done with this module, our architecture would look like this. Yeah, we have a lambda, we have amplify. Where is my amplify? Here we go. Hello world. This hello world is going to communicate with this lambda through API gateway. Okay. Now let's continue further. You'll notice we are at the AWS Lambda service, but it does not yet have a connection to Amazon Web Services Amplify or our users. We'll build that out on the next module. Okay, so let me move this here after my divider and continue with the next module. I'll keep the modules open. So link serverless function to web API, web app. Deploy your serverless function with Amazon API gateway. Okay. Now we are going to create an API gateway. In this module, we will use Amazon API Gateway to create a RESTful API that will allow us to make calls to our Lambda function from a web client. Typically refers to a user's web browser. API Gateway will act as a middle layer between the HTML client we created in Module 1 and the serverless backend we created in Module 2. What you will learn: create a new API using API Gateway, define HTTP Hypertext Transfer Protocol methods on your API, trigger a Lambda function from API, enable CORS, that's cross-origin resource sharing on an API so you can consume it from a website, test an API created with API Gateway from Amazon Web Services Management Console. Key concepts: RESTful. API RESTful stands from representational state transfer, and it is an architectural pattern for creating web services. API stands from application programming interface. Those are RESTful. API is one that implements that architectural pattern. We already read that, but it's good to repeat it again. HTTP request methods. HTTP methods are designed to enable communications between clients and servers. Methods like get or put, defined by HTTP protocol, are used to indicate what action to take on a resource. CORS. The CORS, cross-origin resource sharing mechanism, uses HTTP headers to tell a browser to allow a given web application run at one origin domain and have permissions to access selected resources from a server at a different origin. This problem exists because of the same policy, the same origin policy of the browser. For example, asynchronous communication of one web page to the server can be done only if the service which we are accessing from the web page and the web page are located in the same domain. What if the domains are different? As usual, then we have to allow the CORS on the server. Edge optimized, a resource that uses an AWS global infrastructure to better serve clients all over the world. Okay. Create a new REST API. Log into API Gateway console. Let's do that. Okay. There are a lot of moving parts, even though the application is quite simple. Okay. So HTTP API, WebSocket API. Let me read HTTP API. Build low latency and cost-effective REST APIs with built-in features such as OpenID Connect and OAuth2 and native CORS support. Perfect. Works with the following: Lambda, HTTP backends. Okay. WebSocket application API. Built a WebSocket API using persistent connections for real-time use cases such as chat applications or dashboards. Works with the following: Lambda, HTTP, Amazon Web Services. REST API. Develop a REST API where you gain complete control over the request and response along with API management capabilities. Works with the following: Lambda, HTTP, Amazon services. Okay. REST API private. Create a REST API that is only accessible from within the virtual private cloud. Works with the following: Lambda, HTTP, Amazon Web Services. So in fact, they all work with lambdas. Probably this is our choice, but let's continue reading. Click the orange Create API button. HTTP API, WebSocket API, REST API, REST API private. Probably this one. Find the REST API box and click the orange button, build button in it. So yeah, this one. I already clicked, I already followed the first instruction. On the console, the protocol, select REST. Okay, build. Welcome to Amazon Web Services API Gateway. To create your first API, we have pre-populated the import from with a pet store API defined using Swagger 2.0. To get started, close this model and select import in the create API form. Did I choose the fail warnings? New Virginia? No, I'm gonna go to US Oregon. Okay. On the create new API, select new API. Okay, we're gonna go with new API. Under the create new, select new API. In the API name, put Hello World API. Okay, we're gonna put Hello World API. API name, Hello World API. Okay. Description, endpoint type, edge optimized, global, private, and region, Oregon. Okay. Everything is on Oregon. I created Lambda there. So select edge optimize in the endpoint type drop down. Now, edge optimized endpoints is best for geographically distributed clients. This makes it a good choice for public services being accessed from the internet. Regional endpoints are typically used for API that are accessed primarily from within the same AWS region. This was my assumption, but they say to use the edge optimized. Okay. Example API import from Swagger or Open API 3. Okay. Well, we are gonna go this way. Click the blue Create API button. Your settings should look like the following. Choose the protocol REST, new API. I didn't have REST, but I clicked, so they changed the UI. Okay, hello world. Let me go here and see. So in Amazon API Gateway, a REST API refers to a collection of resources methods that can be invoked through HTTPS endpoints. Okay, this is exactly what I want. I think we are good to go. Create API. Mamma mia. Stages, resources. It looks complicated right now, to be honest, but let's follow the instructions. So create a new resource and method. In the left navigation, click on the resources under your Hello World API. I'm on resources. When the /resource selected, click create method from the action drop down menu. Okay, so this is selected, actions, create method. Create resource, enable course, edit resource, deploy API, import API, edit API documentation, delete API. Okay, so create method. At least this is what I read. Action drop down, select post from the new drop down appears, then click on the check mark. Okay, so post, click on the check mark, and integration type right now. Drop down appears, click on the check mark, select Lambda function from the integration type. We're going to integrate with the Lambda function, okay, US-WES2, and I guess I have a function here on the Oregon, which I named Hello World Lambda, as far as I remember. Type in Hello World function into the function field. This is the name we gave to Lambda function. I hope there is no select, but probably it's not giving me error, so that's a good sign. Click the blue save button. It's gonna be much better if it gives me to choose my Lambda functions from this region, but you're about to give API Gateway permissions to invoke your Lambda function. Okay, this is exactly what I want. Okay. Let's wait and see what happens. Wow. Post method execution. It's interesting. Click the blue save button. You should see a message letting you know you're giving the API, you're creating permissions to call your Lambda function. Click OK. When the newly created post method selected, select enable course from action drop down menu. You created post method, select it. Okay, the post method is selected, and I have to say allow course, enable course. Enable course? Yeah, enable course. I will allow right now this post method to be executed. Enable course. Method post enable course and replace existing course headers. Let me see if I have to add something different. Leave the post checkbox selected and click the blue enable course and replace existing course button. Post. Let me look at if it looks the same. Yeah, it looks the same. Default post, content type, and this is empty. So yes, replace existing values. Now, instead of next to the post, I have options. I hope I did everything correct. Anyway, you should see a message asking you to confirm method changes. Click the blue yes, replace existing values, deploy API. In the actions drop-down menu, a list, select deploy API. Shall I click here? Options, post. In the action drop-down list, select deploy API. Select new stage. In the deployment stage drop-down list, enter def for the stage name. Choose deploy, copy and save the URL next to the invoke URL. You'll need it in the module 5. Validate API. Okay, it doesn't say actually where to click here. That's fine, but it doesn't say deploy API. So probably it doesn't really matter where do you click in the actions. Deploy API, API actions. Let me choose something else and see if the actions actually change. They do change. So shall I click on post and deploy? Actions. Delete method. Edit method documentation, create method, create resource, enable course, edit resource. If I click here, create method, create resource, enable course, edit, deploy. Deploy API. Deployment stage, new stage. Okay, action, deploy API, new stage. In deployment stage drop down list, enter def on stage name. It's chosen. I already typed def. Stage description, deployment. Okay, and click deploy. Copy and save the URL next to invoke URL. You'll need the module 5. Okay, so deploy, and I should be getting one URL. Yeah, here we go. Invoke URL. I'm gonna copy and paste this one here. Invoke URL. I'm curious to see what do we have here. Enable API cache, default method throttling, enable throttling, RAID burst, web application firewall, web ACI access control list, logs, tracing, stage variables, SDK generation, export as Swagger plus API gateway, export as Swagger open API 3, export as Swagger Postman extensions, deploy history, documentation history, canary, whatever that means. Okay, so def, this is what I have, post, optimize, whatever it is, validate API. On the left nav, click on the resources. Click on the resources. Okay. The method post of our API will now be listed on the right. Click on the post. Clicked on the post. Okay. Click on the small blue lightning bolt. Clicked on the lightning bolt. Path, my path, request body. Paste the following. Request body. And hit test. Okay, let me see now what happens. Request status 200, latency, response body. Grace Hopper. Did I send Grace and Hopper? Yes, I did. Okay, so that works. Click the blue test button. On the right side, you should see a response with code 200. Great. We have built and tested the API that calls our Lambda function. Yeah, that's true. That's quite true. Response body. At least I can see here the response body, response header, logs. Okay. So we have done the module 3. Module 3 is now complete. Time to review our architecture. Amazon Web Services Amplify, Amazon API Gateway, Amazon Web Services Lambda. We added API Gateway and connected it to our existing Lambda function. Now we can trigger our function with an API call. We are still missing the ability to generate this call from our web client. We'll add our data table first in module 4 and connect everything together in module 5. Okay. Let me move this to the right of my divider. Now we are on module 4. open link in new tab. Now build a basic web application. Module 4, here. Yeah. Create a data table. In this module, you will create a dynamic database table and enable your Lambda function to store data in it. Wow. In module 5. Introduction. In this module, we will create a table to persist data using Amazon DynamoDB, NoSQL database. DynamoDB is a key value database service, so we don't need to create a schema for our data. It has consistent performance at any scale, and there are no servers to manage with using it. Additionally, we will use Amazon Web Services Identity and Access Management, a IAM service, to securely give our services the required permissions to interact with each other. Especially, we're going to allow the Lambda function we created in module 2 to write to our newly created DynamoDB table using an identity and access management policy. In order to do this, we'll use the Amazon Web Services SDK, Python, JavaScript, or Java from the Lambda function. What you will learn: create a DynamoDB table using the Amazon Web Service Management Console, create a role, and manage permissions with identity and access management. Write a DynamoDB table using Amazon Web Services SDK, Python, JavaScript, Java. Key concepts: persistent data. Let me do something. Yeah. Okay, so let me see. So persisting data, storing data so we can access it in the future independently from program execution. Non-relational database. A non-relational database does not use a tabular scheme or rows and columns. Instead, they use a strong storage model that's optimized for the specific requirements of the type of data being stored. Key value database, a type of non-relational database that stores data as a collection of key value pairs in which a key serves as a unique identifier, primary key, the value that will identify each piece of data in DynamoDB table. This value will also serve to partition the table to make it scalable. Schema, the organization of data that serves as a blueprint for how a database should be constructed. Amazon Web Services SDK, Software Development Kit stands from Software Development Kit. Amazon Web Services SDK provides a set of tools, libraries, documentation, code samples, process, and guides that allow developers to create software applications on a specific platform. IAM policy, a document that defines what Amazon Web Services resources an entity, for example, service user group, has access to. Implementation: create a Dynamo table, log into Dynamo console. I love that. I love that. Just notice this. Just notice the URLs. DynamoDB. The rest is the same. If you go to the services here, you will see the same here. Lambda. Okay, so let me take a look now. What do we have and how are you going to do that? So we are on the console, create table, create tables, create Dynamo tables, DynamoDB API reference, add a query item, monitor and manage tables. We have a beacon button which says create table, so this is what we're going to use. Make sure you know that region you're creating your function in. We created in Oregon, so let me make sure that I'm in Oregon. Yes, I am here. I'm in Oregon. On the page next to your account name, click blue create button. Next to the table name, click type hello world database. So Create table. Table, in fact, is a collection. Okay, hello world, primary key. Partition key, primary key probably is gonna be ID. Primary key type ID. Add short key, sort key. We'll see what does it say here. Click the blue create button, copy the table Amazon resource name from the right hand panel. You'll need it later on this module, okay? The primary key, okay, string, table settings, use default settings, no secondary indexes, provision, blah, 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 blah. Okay. Kinesis data streams for Dynamo is now available. The preview DynamoDB console is now available. I'm going to read this later. Click on the create, and now we need Amazon resource network. Okay, let me see where it is. Dynamo stream details, latest stream ARN, manage Dynamo stream. Hello world, blah 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 blah, create. Not applicable, manage time. Here we go. Amazon resource name. This is the Amazon resource name. Is going to be used in Lambda to connect to this resource. Amazon resource name. ARM, AWS, DynamoDB, use West2, and this unique name, unique identifier. Okay, so let me see what next. Create an @IAM policy to Lambda function. Now that we have a table, let's edit our Lambda function to be able to write data to it. In a new browser window, open the Lambda console. I have it open already here. I'm not going to open it again. Click in the function we created, module 2. If you want, hello world function, we will be adding permissions to our function so it can use the DynamoDB service, and we will be using Amazon identity access, okay, management. Click on the permissions tab. We'll go here. Permissions. Test monitor configuration. Yeah. I guess it's here. They have changed it. Permissions tab. And now what? Hello world function role, blah 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 blah. Now let's continue. Permissions tab. In the execution role box, click on the role. In the execution role. Execution role name. Click on the role. Role is a unique, so let me click on the role. It's global. Let's continue reading here. In the execution role, click on the role. A new browser tab will open. Click on Add Inline Policy in the right of the Permission Policies box. Add policy, attach policies. This is the Lambda function. Edit role description. Policies. Identity policy. Let me read it again. Click on in the execution role, click on the role, click on Add Inline Policy on the right of the Permission Policies box. Add Inline Policy, here we go. Attach policy, add inline policy. Okay. And now what? Click on the JSON tab. JSON tab, and probably they're gonna give us something to copy and paste. Paste the following policy in the text area taking care to replace your table's ARN in the resource field on line 15. Okay. So your table ARN. Okay. So let's go here. Statement version 2012 1017. Let me look at here. What do we have here? Version, and their errors, of course. What kind of errors? One error. Show me the error. Missing iron field. Yeah, of course. So let me copy again the iron of the database and put it here and see if the error is gonna disappear. Okay, that's fine. So let me take a look. Version statement sit, some kind of a visual editor. 0 effect allow action DynamoDB put item, delete item, get item, scan query, update item. Resource. Okay, so that's it. These policies are quite complicated story. Preview policy. Then DB. This policy will allow a lambda function to read, edit, or delete items, but restrict it to only be able to do so in the table we created. Okay. Click the blue preview policy. Next to name, type hello world dynamo policy. Hello world dynamo policy. Limited read write. Okay. Table names string like hello world database. Okay. DynamoDB. Allow one of 277. I was thinking there 157. Click the blue create policy button. You can now close this browser tab and go back to the tab for your lambda function. Okay, great. Create policy, and we just have created a new policy called hello world dynamo policy inline policy. Now we gotta go back to our lambda, click on the code probably and change the code. Modify lambda function. Okay, JavaScript, include const. Now let me copy this. Replace the code for your function with the following. It's gonna connect right now to the database. I'm just curious to see where do we use go to our lambda. Let's go to the code of the lambda. Execution. I'm gonna remove this execution. I'm gonna even comment out this one. This is step number 2. Paste it. Let's take a look at the code. Amazon Web Services require Amazon SDK. Okay. Let DynamoDB new Amazon Web Dynamo document client. Okay. Date, new date. Okay. Now date to ISO string. Okay. Export handler async event, extract value from. Okay. So whatever comes from the event will be here. Let params, table name, hello world database, item, latest greeting time now. DynamoDB. Here we don't put the connection string to the database. Then we put params promise, const response, status code. Probably that's why it's in the same region. Even though somebody else also can call his function, his table, hello world database, table name, stringify, whatever, blah blah. Okay, let me continue reading here. Okay. Click the orange save button on the top of the page. I don't see any place where I can put the connection string. So I'm gonna save this, and as usual I have to deploy it. Deploy this. I can even test it right now and go to the Dynamo and see if it works. But let me follow this. Say button, test the change, click white test button. It's not white, it's orange. You should see an execution result succeed message, green background. In the new browser tab, open the DynamoDB console. I have it already opened, but let me test the execution right now. Now, status code 200, body hello from lambda log name. The test event hello world test was successfully saved. Status succeeded, maximum. Okay, let me read. You should see your execution result succeeded message with a green background. I saw it. In a new browser tab, open DynamoDB console. I have it opened already. Okay, hello world database. Let me see the items. Table name, I don't see anything here. Okay. Click on tables on the left hand navigation bar. Click on hello there. Click on the items tab. Items matching your test event should appear here. If you have been using our example, the item ID will be Ada Lovelace. I don't see anything. Okay, let me close this. Oh, hello from Ada Lovelace. Hello from Lambda, Ada Lovelace. Yeah, he finally appeared. Okay, so success. Every time your Lambda function executes, your DynamoDB table will be updated. If the same name is used, only the timestamp will change. Really? Okay, so let me notice this. 11:54:28. Let's test it again. Close this. Again. 11:54. 11:54. Test. Okay. Let's go back. Still 11:54. Scan. What is the way to refresh it? Click again. I'm gonna refresh the entire page because I don't see the button for refreshing. So, hello world. 11:54:28. I don't see any change. 11:54:28. Come on. That's it. So at least we have finished this module, application architecture. With module 4 complete, let us look our current architecture. We have Amazon AWS Amplify, the gateway, the Lambda, identity and access management has fixed the permissions of the Lambda so it can access the Amazon Dynamo. We added two services in this module, DynamoDB for storage and IAM for managing permissions securely. Both are connected to our Lambda function so that it can write to our database. The final step is to add code for our client. Okay, so let me move this to the right of my divider. And we will continue with the next module, the next and the last. Okay, module number 5, add interactivity to web application. Open link in a new tab. What we did is with Amplify we uploaded a zip file of our application. Now we're gonna change our application locally, zip it again, upload again, and it's gonna be deployed. That's it. Okay, so let's follow this. Module 5, add interactivity to your web application. In this module, you'll modify your static website to invoke your API and display custom input text. Introduction. In this module, we will update the static website we created in module 1 to invoke the REST API we created in module 3. This will add the ability to display text based on what you input. What you will learn, look at again the structure, introduction. I even have it in the here in a mind map. In the mind map probably is better to see it. What is the full stack development? What is the getting started? Overview, what you will learn, modules. Each module has the very same things. There you go. Over here. If you look at the branches, everywhere, introduction, what you learn, key concepts, implementation. Wonderful, just wonderful. This documentation is really good one. Again, module 5, again the same thing, introduction, what you learn, key concept, implementation, architecture. Okay, so what you will learn, call an API gateway, API from the HTML, upload a new version of the web app to amplify console. It's still not automated. In the next tutorial, probably we will do automation. We will build a CI/CD pipeline when we push to master branch in Git. The application is going to be built and deployed. Key concepts: deploying a website, making a website available to users, environment, a stage such as prod, dev, or staging, where an application or website can be executed, invoking an API, sending an event on API to trigger a specific behavior, implementation, this is the meat. Open the index HTML file you created in module 1, replace the existing code with the following. Now, this is what we have. I'm gonna call this version 1, for example. I have the HTML open here. Let's try to understand, not blindly, just copy whatever we have. So add some CSS to change the client UI, background, okay, here it is, the style. After that we have a script. Okay, let me copy this. Here it's supposed to be in the head. The style is straightforward. Body, background, label, button. Okay, so script. For call API, first name, last name. Define the call API function that takes a first name and last name as parameters. Instantiate a headers object. My headers, new headers. Add content type header to object. My headers, append content type application JSON. Role, JSON stringify, first name, last name, okay? First name and last name will come from the form. Request options, method post, headers, body row, make API call with parameters, your API invoke URL. Okay, so body JSON, blah blah, invoke URL. This is actually our URL. API Western request options. Okay, so that's it. Follow first name, last name, JSON, stringify. So it's gonna send JSON. JSON stringify first name, last name. Yeah, this is what's gonna happen. Redirect follow. Redirect follow. Okay, so let me go back to the code, and we have to add the form. Of course, we can keep hello world. That's not a problem. Hello world will stay above the form. Into the form we have label first name, that's okay. Input type text, ID, f name. Label last name, type text ID. Notice we are not gonna submit this with a submit button. We are gonna put just a normal button, which is not submitting the form. Type button. On click, call API, document, get element by ID, f name. So in fact we are getting the element f name value, the value of this element. After that, document get element by ID value, and that's it. Call API. So this is what's gonna happen. Dynamic behavior. On click of this button, we're gonna call this function. We are sending two formal parameters. We are sending the arguments, and the arguments are taken from the input fields, f name, and here last name. Fetch, and we are using promises here. They use promises instead of async await. Request options, then response text, whatever we get after the request, and once we get the response, result alert JSON parse result body. So we're gonna get one alert window, and on errors we'll catch the error console log error. Okay, that's it. Now let's continue reading. Make sure you add your API invoke URL on line 41. On module 3 our line is different, but I have added the URL. Note, if you don't have your API URL, you can get into the API gateway console, which is supposed to be somewhere here. Yeah, API gateway console, Amazon API gateway, and let's see what do we have to do in order to get the API. By clicking on your API and then on stages. Stages, dev. I don't see, to be honest, I don't see the URL, but maybe it's somewhere here. Enable API cache. Web application firewall, web ACL, create client certificate. Oh my god. It's here, of course, on the blue. So let me make sure it is the same. Yeah, XMTBW, blah 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 blah, Amazon West to Amazon Def. Okay, so we have it. Just for curiosity. Save the file, zip compress only HTML, open the Amplify console, click on the web application. Okay, let's follow these instructions. Now what we have to do is just zip the file again, zip it. We're gonna upload this file, the Amplify console. Where was it? Here we go. Amplify console, choose file, deploy successfully completed. Let's follow. Click the web application, create in module 1, click in the white choose file button, select zip file. So it's here, choose file. If you go directly to Amplify console, let me do that actually, you will see the applications you have here. Click on this one, And here we go. We get to the same point, to the very same stage. So here I'm gonna choose file, again index, open, and it's deploying right now. Deploying 70%. Deployment successful completed. Let me refresh now and see what happens. Okay, so we have hello world. We have, I'm gonna put my name, Stoyan call API, and let's see what happens now. Def blah 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 flip.com. Hello from Lambda Stoyan Chereshov. Okay, this is what we got back. Now, if I go to the database, I should be able to see the record. Total read. Is it working? Is it doing something? Come on. Default. How to click on that so it opens actions. Hello world database. It's counterintuitive right now. Hello world. Okay, guys. Okay, so finally it worked somehow. Items. Let's see the items. Here we go. Hello from Lambda Stoyan Chereshov. And it's 12:45. Okay, let me try and see if I call it again. Is the timestamp gonna change? Because this one didn't change as expected. It just stays the same. Maybe the principle is if it's already recorded, don't change it. 11:54, this is 12:45. So let me try again. It says hello from Lambda Stoyan Chereshov. It's supposed to be written into the database, and I don't see anything like that done. So scan, query, refresh. I finally found it. So it stays 12:45. It just doesn't replace the timestamp. At least I think doesn't change. If this plays the role of the ID, the unique ID, and if the record already exists, it's not replaced. Since we don't know exactly the requirements of the user, we will accept that this is the required behavior. So we're not gonna change anything right now. Again, refresh. 12:45. So it doesn't change. Click on the web create in module 1. Click on choose file. Select zip file. Then, when the file is uploaded, deployment process will automatically begin. Once you see green bar, your deployment will be completed. Click on the URL on the domain. Your update web app should load in the browser. Fill in your name or whatever you prefer and click the Call API button. You should see a message that starts with hello from Lambda followed by the text you filled in. Congratulations. You now have a working web app deployed by Amplify console that can call a Lambda function via API, which is just amazing. Now this API, of course, should have different endpoints. Right now it's just def. But if we read the documentation here we go. We could create another endpoints which are gonna call another Lambda functions. This is how it's supposed to work. Joe. Okay, so something else. Joe Schmo. Call API. It's 1549. Let's see if it happens. At least, okay, so it doesn't actually pull the data automatically. Joe Schmo. 5045. What? 1245. Look at this. 1245. I did this much later than this record, and it gives me the exact same time. That's ridiculous. Okay, whatever it is, I'm gonna figure this out. It's not important right now. So the application architecture with all modules now completed. Here is the architecture of what you built. I access the Amazon Web Services Amplify here. Yes, I do that. Joe Schmo. This is the URL. After that, when I press the button call the API, the static page actually communicates with the API gateway, and especially with the endpoint def, because we could have named this differently. Now def probably should be called something else. And this def on its turn calls the Lambda. Lambda is set up, the Lambda permissions are set up so the Lambda can access the Dynamo and it records something into Dynamo. Perfect. All the Amazon Web Services, AWS services we set up can securely communicate with each other. When a user clicks on a button in web app, it makes a call to our API, which triggers our Lambda function. Our Lambda function writes to a database and returns a message to our client via API gateway. All permissions are managed by identity and access management. Identity and access management is this thing with the key. Console, look at this. IAM, when we're talking about the Lambda, the only thing that changes is the Lambda. When we talk about the database, the only thing that changes is a database. And you also have a home everywhere, so it's easy to remember. Of course, it starts with the region. Okay, so that's it. Was this module helpful? Yeah, it was very helpful. Feedback. That was it actually. No, I'm not going to continue right now. Okay, thank you very much. The last thing we have to do, of course, we don't have to forget to clean up whatever we have created. So, probably I should start with the first thing we have created as a stack. Is this a stack? No, this is like a queue. Data structure. The first thing we have created, the first thing is we are gonna delete. So what I'm gonna do is I'm gonna delete my front end. In this case, at environment. In this case is the application getting started. Delete application. Don't forget to clean up because Amazon is gonna charge us otherwise. So now it shouldn't respond anymore. Yeah, this XML file does not appear to have any style information associated with it. The document 3 is shown below. Code access denied, 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 blah, 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 blah. Okay, so this is what we got. When we delete the application from Amplify, now hosting, we don't care about that. We can delete the role which we have created for our Lambda. Why don't we try to delete it from here? Delete function. Delete the function, and we'll see if it deletes the role automatically. Those are all the lambdas. Your lambda function, hello function, was successfully deleted. And those are the functions, amplify login custom message, which we have by default. Let me see right now the role. Maybe I should refresh the page and see if the role disappeared for some reason. Yeah, it's still there. So inline policy, I'm gonna delete this role. I don't need it anymore since I don't have the function, and I don't have, and as soon I'm gonna delete the dynamo as well. Okay, so the lambda has been deleted, the amplify application was deleted. API gateway, delete stage. Now we have to delete the API gateway. How we're gonna do that? Save changes, probably somewhere in settings. Let me see. Hello, configure tags, generate. We have to find a way to delete custom domain names. APIs actually. Let me click here and see what happens. Create API actions. Hello world API. And from the action, we're gonna say delete. So the API gateway is gonna be deleted right now. Okay, so it's deleted. If you don't remember, we have created from here. Okay, so that's deleted. Now the database, hello world database table. Create action, blah, 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 blah. Okay, delete table. Delete all CloudWatch alarms for this table. Create a backup before deleting this table. I don't know. I don't want that. Enter the word deleted. Delete. And so I don't have in Dynamo anymore anything. What else? I think that's it. Let me look at again the architecture and make sure. So I have deleted Amazon Dynamo, the Lambda, the role, the gateway, and first thing I did is I deleted the AWS Amplify. Okay, so now everything should be clean. That's it. We clean it up after we made this mess. Now eventually we didn't forget anything and we don't have to pay extra money. Thank you.